Hi students, here is another question from portal method of approximate analysis for the lateral loads on multi-story frames. Here is our question. The question is to analyze the frame using portal method. This is a two-story frame with the horizontal loads 40 kilonewton and 80 kilonewton acting in the lateral direction at the joints. The height of the column is 3.5 meter each, and the beam span length is given as 5 meter and 7.5 meter. In portal method, there are two assumptions. We know that. First one is point of contact pressure occurs at the middle of all the members of the frame, and second one is the horizontal shear taken by each interior column is double that of the external column or exterior columns. Now we are considering the top floor. Let the horizontal shear taken by the exterior column be P, then the interior column will be 2P. Then taking the equilibrium condition, that is summation of horizontal forces equal to 0. Then we can write the equation as 40 equal to P plus 2P plus P. Then the force on the exterior column is obtained as 10 kilonewton and interior column will be 20 kilonewton. Similarly, for the ground floor, we are taking the pre-body diagram of the ground floor above the point of contact pressure. Let the horizontal shear taken by the exterior column be P, then the interior column is 2P. Then forces acting from left to right, total forces acting from left to right is 40 plus 80, and total horizontal forces acting from right to left is P plus 2P plus P. Then as per our equation or equilibrium condition, they are equal. So P is obtained as 30 kilonewton, that is force in the exterior column is obtained as 40 kilonewton, and the force in the interior column will be 2 times of the exterior column, that is 60 kilonewton. Now we are going to calculate the column moment, beam shear, and axial force in columns. So these are the point of contact pressure in beams and a column. They are occurs at the midpoint of the all members of the frame. Then we know the value of horizontal shear for the column. For the top floor, the horizontal shear for the exterior column is 10 kilonewton and the interior column is 20 kilonewton. And for bottom story or ground floor, the value of horizontal shear for the exterior column is 30 kilonewton and for interior column is 60 kilonewton. Now we are going to calculate the column moments by knowing the values of horizontal shear and also noting the moment at the mid height of the column is 0. Then according to this assumption, the moment at the end of the column will be column shear into height of the column divided by 2. So for column AE at the top end will be 10 into 3.5 divided by 2, that is 17.5 kilonewton meter in clockwise direction. And at the bottom end of column AE, it will be 10 into 3.5 by 2, that is 17.5 in clockwise direction as shown in the figure. For the interior column BF, at the top end, the moment will be 20 kilonewton into 3.5 divided by 2, that is 35 in clockwise direction. And for exterior column CG, it is 17.5 kilonewton meter in clockwise direction as shown in figure. So now for the ground floor, the column moment of EI will be 30 into 3.5 by 2, that is 52.5 in clockwise direction. And for interior column, it is 60 into 3.5 by 2, that is 105 in clockwise direction. Similarly for other column ends. The values of column moments are marked in the figure. Now, by considering the equilibrium of moments at the joints, we can easily calculate the beam moments. Now, consider joint A. The MAB will be the moment. MAB will be 17.5 in anti-clockwise direction, so that the total sum of the moments at joint A will be 0. Then MBA is also 17.5 in anti-clockwise direction. Then MBC will be 35 minus 17.5, that is 17.5 in anti-clockwise direction. Then MCB equal to 17.5 in anti-clockwise direction. Similarly, for the intermediate story, at the joint E, total sum of the moment is 52.5 plus 17.5. Both are in a clockwise direction. So balancing moment will be 17 kilonewton meter in anti-clockwise direction. Then MFE will be 70 kilonewton meter in anti-clockwise direction. Then MFG will be 70 minus 35 minus 105, that is 70 kilonewton meter in anti-clockwise direction. Then MGF will be 70 kilonewton meter in anti-clockwise direction. Now we are going to calculate the beam shear for every beams. Since the moment at the midspan of the beams is 0, then according to this assumption, the beam shear can be marked at the midspan of the beams. So in the top floor, the beam shear will be 17.5 divided by 2.5, that is 5 by 2. 17.5 divided by 2.5, that is 7, acting upward direction. Then on the just right of the point of contact pressure, 7 kilonewton beam shear is acting downward direction. Then for beam BC, the beam shear will be 17.5 divided by 3.75, that is half of the beam span. So 17.5 divided by 3.75, that is 4.67. Then for the intermediate floor, the beam shear for beam EF will be 70 divided by 2.5, that is 28 kilonewton. Then for FG, beam shear for beam FG will be 70 divided by 3.75, that is 18.67. Now we are going to calculate the axial force in the columns. To find the vertical loads or axial force in the column, free body diagram of joints is to be considered. So first of all, we are going to consider the free body diagram of joint A for the vertical equilibrium condition. Then the axial load on of the column AE will be 7 kilonewton acting downwards, or tensile in nature, 7 kilonewton. Now for the bottom story, it will be 35. By considering the equilibrium condition of joint E, 7 kilonewton axial force acting upward in the column AE, then beam shear is 28. So balancing vertical force in the column EA will be 35 in the downward direction. Now for the column BF, it will be 7 minus 4.67, that is 2.33, acting upward direction. Then for column FJ, it will be 28 acting downward direction minus 2.33 acting downward direction plus 18.67 acting upward direction. Then the answer will be 11.66 acting downward direction. Then similarly, we can calculate the axial force or vertical loads in the column for other column.